Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay. Suppose the outer electron in a potassium atom is in a state with L equal to 2. Compute the magnitude of L. What are the possible values of J and the possible magnitudes of J capital? Dear students, now we move to its solution, but before starting its solution in a proper manner, we will go through a few slides which will help us in solving this problem and will serve as a foundation regarding the solution of this problem. Okay. Dear students, first snapshot regarding the solution of this problem is about quantization. Okay, quantization, angular momentum L, magnitude or mod or modulus value is equal to under root small l into small l plus 1 into h cut or h bar or h reduced, where h cut or h bar or h reduced is Planck's constant divided by 2 pi for small l equal to 0, 1, 2, 3 and so on. Okay. Second important point from this snapshot is the z component of L. Lz, here z is written as a subscript of L, is equal to m into h cut or h bar or h reduced, where h cut or h bar or h reduced is Planck's constant divided by 2 pi. Dear students, here small m in some books it is written as ml, where small l is written as a subscript of m. Okay. However, it does not make very much difference whether we denote it by simply m or by ml, while l is written as subscript of m. Okay. For m equal to 0, plus minus 1, plus minus 2 and so on up to plus minus small l. Then third point is about energy. En equal to minus kz e square over h cut whole square into mu over 2h square. This alternatively becomes equal to minus 13.6 z square over n square e electron volt. Okay. Second snapshot is about spin orbiting orbit coupling. Spin orbit coupling. This snapshot says that L and S add to give the total angular momentum capital J equal to capital L plus capital S, where magnitude is given by capital J mod or modulus value or absolute value or magnitude is equal to small j into small j plus 1 whole under root into h cut or h bar or h reduced. Okay, where h cut or h bar or h reduced is Planck's constant divided by 2 pi, where small j is equal to small l plus s or small l minus s magnitude. Okay, absolute value, modulus value of l minus s. Okay, this interaction leads to the fine structure splitting of the energy levels. Okay, so dear students, we will solve our problem in accordance with these two snapshots. Okay, now we come to our solution in a proper manner. Okay, here small l is equal to 2. This implies that capital L or magnitude of capital L vector, that is L bold, is equal to small l into small l plus 1 whole under root into h cut or h bar or h reduced. Okay, where h cut or h bar or h reduced is Planck's constant divided by 2 pi. Okay, this alternatively becomes equal to 2 into 2 plus 1 into h cut or h bar or h reduced. Okay, because we put value 2 in place of small l, so this has become equal to 6 under root into h cut, and 6 under root is equal to 2.449. so here capital L or magnitude of capital L bold becomes equal to 2.449 h cut. Okay, where h cut or h bar or h reduced is Planck's constant divided by 2 pi. Now small l is equal to 2, and we know that spin has always only two values, either plus half or minus half. And we also know that small j is equal to small l plus s. This is just a formula as explained in the snapshots which we have included in our problem. Okay, so this implies that small j becomes equal to 2 plus 1 by 2 and 2 minus 1 by 2. Okay, because one time we will take a plus value of spin, while second time we will take a negative value of spin, minus half. So j becomes equal to 5 by 2 and 3 by 2. Okay, two values of small j have been obtained. Now we move forward. Now capital J or magnitude or absolute value or modulus value of j vector, that is j bold, becomes equal to small j into small j plus 1 whole under root into h cut or h bar or h reduced. Okay, where h cut or h bar or h reduced is Planck's constant divided by 2 pi. Okay, now this implies that because we have two values of j, so one by one we will find capital J for both these two values of small j. Okay, first we take the value of small j which is equal to 3 by 2, then we will take 5 by 2. Okay, when we take small j equal to 3 by 2, then capital J or magnitude or modulus value or absolute value of j vector, that is j bold, becomes equal to 3 by 2 into 3 by 2 plus 1 into h cut or h bar or h reduced. Okay, where h cut or h bar or h reduced is Planck's constant divided by 2 pi. This alternatively becomes equal to under root into 3 by 2 into 5 by 2 into h cut or h bar or h reduced, and this becomes equal to 15 by 4. And when we divide 15 with 4 and then take its under root value, then it becomes equal to 1.94. Okay, hence our capital J or magnitude of j vector, that is j bold, becomes equal to 1.94 h cut or h bar or h reduced. And now once again j equal to capital J is equal to magnitude of capital J vector or capital J bold becoming equal to j small j into small j plus 1 under root into h cut or h bar or h reduced, where h cut or h bar or h reduced is Planck's constant divided by 2 pi. Now we are going to take into consideration the other value of small j. Okay, because in previous part of this problem we have calculated two values of small j. Okay, that is 3 by 2 and 5 by 2. We have used the value 3 by 2 and now we are utilizing this value, the j equal to 5 by 2. So this implies that when we use this value in the above formula, that is j equal to j vector magnitude equal to small j into small j plus 1 under root into h cut, then capital J or magnitude of capital J vector or capital J bold becomes equal to 5 by 2 into 5 by 2 plus 1 into h cut or h bar or h reduced. This alternatively becomes equal to 5 by 2 into 7 by 2, and this is into h cut or h bar or h reduced, and this is equal to 35 by 4 under root into h cut, and when we divide 4 by 35 and then take its under root, then it becomes equal to 2.96. Okay, hence our capital J, or magnitude of capital J vector, that is capital J bold, becomes equal to 2.96 h cut, where h cut is the h cut or h bar or h reduced is the Planck's constant divided by 2 pi. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.